You think reality is the stuff that's really there, the things you can see, touch, measure. Tables are real. Stars are real. Your body is real. Thoughts might be questionable, but the physical world feels solid enough. Reality, you assume, is whatever exists independently of you. That assumption is doing far more work than you realize, because the moment you ask what independently means, the idea of reality you've been carrying around starts to wobble. Not collapse yet, just wobble. And that wobble is where the interesting part begins. You were taught implicitly that reality is made of things, objects with properties, locations in space, durations in time. The job of science, you were told, is to describe those things accurately, measure them better, label them more precisely. Physics does not actually work that way. Physics does not start with things. It starts with interactions, with what happens when systems affect each other, with records left behind, with correlations that persist. This is not a philosophical choice. It is forced on us by experiment. Take something simple, an electron. You probably imagine it as a tiny particle, a little dot moving through space. That image feels harmless. It's also wrong in almost every way that matters. You never see an electron. You never touch one. You infer its existence from what it does. A streak in a detector, a deflection of a beam, an energy transfer. The electron is a name you give to a consistent pattern of interactions. There is no extra thing hiding underneath the pattern. That's already a problem for the everyday idea of reality. Because if the most basic building blocks of the universe are not things but patterns, then reality is not made of objects. It's made of relationships. Now extend that idea outward. Space feels like the place where reality exists, an empty container waiting to be filled. But physics does not describe space as a passive stage. Space is not something that exists independently of what's in it. It bends, it stretches, it curves, not metaphorically, literally. This is what gravity is. Gravity is not a force pulling things through space. That description is already a compromise. Gravity is the geometry of space-time itself. Objects move the way they do because space-time tells them how to move. And space-time is shaped by what exists. There is no container separate from the contents. Space is part of the interaction. Time, which you probably think is the most obvious part of reality, fares even worse. You were taught that time flows, that there is a universal clock ticking in the background, keeping reality synchronized. Physics does not describe anything like that. There is no universal time. There are clocks, and clocks disagree. Two identical clocks placed in different conditions record different amounts of time. One moves faster. One sits deeper in gravity. One ticks less. Not because it is broken, because time itself behaves differently along different paths through space-time. If time were a background flow, clocks would simply read it off. They don't. And physics sides with the clocks, not with your intuition. This already tells you something uncomfortable. Time is not a thing that exists on its own. It is not a substance. It is a way of ordering events along paths. Now combine this with relativity, and another illusion vanishes quietly. The idea of a universal present. You think there is a single now shared by the entire universe. A moment that cleanly separates what exists from what doesn't yet. That idea feels so natural that questioning it feels like wordplay. Relativity makes it impossible. Two observers moving relative to each other do not agree on what events are happening right now. What you call present, another observer can legitimately call past or future. Both are correct. The laws of physics allow both descriptions. There is no privileged observer, no master clock, no cosmic present, which means now is not a feature of reality. It is a feature of perspective. Once that is gone, the idea that reality consists of what exists right now loses its foundation. If there is no universal now, then reality cannot be defined as everything that exists at the present moment. The present moment is not a global concept. Physics never says the past is real and the future is not. That distinction came from memory, not from measurement. You remember the past. You don't remember the future, so the past feels solid, and the future feels empty. Physics does not confuse what you can access with what exists. Events in the future are treated just as seriously as events in the past, in the equations. Predictions and retrodictions use the same machinery. The laws do not care which direction you point time. This is why physicists talk about space-time as a four-dimensional structure, not because it sounds abstract, but because it is the only way to describe reality without smuggling in human-centered assumptions. In that structure, events do not pop into existence as time flows. They are located. They are related. They are part of the whole. This is the first sense in which reality is not what you think it is. It is not a collection of things appearing and disappearing in time. It is not a sequence of moments replacing each other. It is a network of events connected by lawful relationships. From inside that network, you experience change. You experience memory. You experience anticipation. You experience a sense of now. None of that is denied. But none of that defines what reality is. Reality is not what you are currently aware of. Reality is what remains consistent when perspectives change. This is the part that usually gets skipped in school, because it doesn't fit nicely into diagrams. You were taught to think that reality is what exists independently of observation. Then you were taught that observation somehow interferes with reality, especially in quantum mechanics. Both pictures miss the point. Observation is not a magical act. It is an interaction. When you observe something, you are not revealing a hidden object. You are participating in a relationship that leaves a record. That record is what physics uses. Reality, in this sense, is not made of things waiting to be seen. It is made of interactions that can be consistently described. Once you accept that, the question, what is reality, stops being mystical and starts being technical. Reality is not what feels solid. It is not what feels immediate. It is not what is happening now. Reality is the structure that accounts for all possible interactions, across all perspectives, without contradiction. That structure does not care about your intuition. It cares about consistency. And that is why, the deeper you look, the less reality resembles the picture you started with. If reality is not made of objects, then what exactly is it made of? This is where people often expect a dramatic answer. Some new substance, some deeper layer hiding underneath matter and energy. But physics does not deliver surprises that way. It delivers reductions. What it keeps reducing reality to is structure. When physicists talk about fields, they are not talking about invisible stuff filling space like fog. They are talking about mathematical entities that assign values to events. A field tells you what can happen, how strongly, and how events influence each other. The field is not a thing sitting somewhere. It is a rulebook written into the structure of space-time itself. An electromagnetic field does not exist the way a chair exists. It exists in the sense that it constrains interactions. It determines what happens when charges are present. You never observe the field directly. You observe its effects, and those effects are enough to treat the field as real. This should already be unsettling, because it means reality is being defined by what influences what, not by what sits where. Now push that idea further. In quantum mechanics, even the idea of a definite state becomes slippery. Systems do not carry around a list of properties waiting to be revealed. They carry a set of probabilities. Those probabilities are not a statement about ignorance in the everyday sense. They are part of the structure of the theory. Before an interaction, asking what a system really is often has no answer. After an interaction, you get a record, a result, something you can point to. Reality, in this framework, is not a static inventory. It is a sequence of correlations. This is why quantum mechanics feels so hostile to common sense. Common sense expects reality to be definite even when no one is looking. Physics says definiteness is something that emerges through interaction. That does not mean reality depends on human consciousness. That is another illusion people rush to. It means reality depends on physical interaction. A measuring device, a particle, an environment, something that leaves a record. Records are the key. The past feels real because records of it exist. Fossils, photographs, memories, radiation from distant stars. The future feels unreal because records of it do not yet exist for you. That difference feels like a difference in existence. It isn't. It is a difference in information. Physics never defines reality in terms of what is recorded. It defines it in terms of what can be recorded. That subtle shift matters. Once you see it, the everyday idea that reality is what's happening right now becomes impossible to defend. What's happening right now for you is just the set of records currently interacting with your nervous system. It is not a privileged slice of existence. Reality does not care where your attention is. Now return to space and time with this in mind. Space is not where reality sits. It is part of the structure that determines which interactions are possible. Time is not when reality updates. It is part of the structure that orders correlations along paths. Neither one is fundamental in the way you were taught. Both are emergent aspects of a deeper relational framework. This is why attempts to ask what is really there underneath everything tend to fail. Underneath is not the right metaphor. There is no basement layer of reality made of tiny objects with intrinsic properties. What there is instead is a network of constraints, laws that limit what can happen, symmetries that restrict behavior, invariants that remain the same when perspectives change. Reality in physics is what stays consistent under transformation. Change reference frames, change coordinates, change descriptions. Reality is what survives all of that. This is why the universe resists being pictured. Pictures freeze a perspective. Physics refuses to privilege one. And now we come to the part that most people never fully accept. The idea that reality is not something you are observing from the outside. You are inside it, embedded. Your thoughts, perceptions, and questions are themselves physical processes governed by the same laws. There is no external vantage point from which to say, this is what reality really is. There are only internal descriptions that agree on invariance. This does not mean reality is subjective. It means objectivity is achieved differently than you were taught. Not by finding a single true picture, but by finding relationships that all observers must agree on. That is a harder kind of objectivity. And it is the only kind physics knows how to deliver. Once you accept that, the question, what is reality actually, stops sounding philosophical and starts sounding. Once reality is no longer made of things, and no longer defined by what exists right now, something uncomfortable happens. The boundary between observer and observed starts to blur, not in a mystical way, in a structural one. You were taught to imagine yourself as standing outside reality, looking at it. Physics does not support that picture. You are not a spectator. You are part of the same network of interactions you're trying to describe. Your eyes detecting light are physical events. Your brain forming thoughts are physical events. Your question, what is reality, is itself a physical process unfolding along a world line. There is no clean cut between reality and your experience of it. Experience is something reality does. This is the part that makes people uneasy. Because it sounds like it's dissolving objectivity. It isn't. It's redefining it. Objectivity was never about removing observers. It was about finding descriptions that do not depend on which observer you are. Physics achieves that not by pretending observers don't exist, but by showing how all observers fit into the same structure. When two people disagree about what they see, physics does not ask which one is right. It asks what transformation relates their descriptions. If the transformation works, both descriptions are valid. Reality is what survives that translation. This is why the universe does not give you a single authoritative picture. It gives you a set of rules for relating pictures. The mistake was thinking reality had to look like something from one point of view. Once you let that go, the idea of reality stops being fragile. It becomes robust. Now consider how different this is from the way you were taught to think. You were taught that reality is out there. independent, fixed, waiting to be discovered. Then you were taught that quantum mechanics somehow made it fuzzy, as if uncertainty were layered on top of an otherwise solid foundation. The truth is harsher and cleaner. Reality was never a collection of definite things to begin with. It was always a structure defined by relationships. Quantum mechanics didn't make reality weird. It exposed how wrong the old picture already was. Definiteness is not the default state of the universe. It is something that emerges when interactions produce stable records. Before that, asking what something really is may have no answer. That doesn't make reality subjective. It makes it conditional. Reality is what is constrained by the laws, not what fits comfortably into language. This is why Feynman was so insistent on separating explanation from description. He knew that the moment you try to explain reality in everyday terms, you smuggle in assumptions that don't survive scrutiny. You replace structure with story. Stories want characters, timelines, and clear causes. Reality offers correlations, symmetries, and equations that don't care how the story sounds. The deeper you go, the more this pattern repeats. Every time you ask, what is really happening, you are tempted to answer with a picture. And every time, physics quietly removes the picture and leaves you with relationships instead. That can feel like loss. It isn't. It's a trade. You give up intuitive certainty and gain consistency. Now look back at the original question. What is reality, actually? It is not matter. Matter is a pattern in fields. It is not space. Space is part of a dynamic geometry. It is not time. Time is a coordinate ordering relations. It is not observation. Observation is interaction. Reality is the total structure that makes all consistent interactions possible. That sounds abstract, because it has to be. Anything concrete enough to picture is already too small. Reality is not what you can point at. It is what you cannot remove without breaking the predictions. This is why physics keeps converging on mathematics. Not because mathematicians like symbols, but because mathematics is the language of structure without pictures. It lets you describe relationships without pretending they are things. The universe is not hiding behind the math. The math is the universe, in the only form that does not privilege a perspective. From inside that structure, you live a life. You make choices. You experience meaning. None of that is threatened by this view. It is explained by it. Meaning is not a property of the universe as a whole. It is a property of subsystems capable of valuing outcomes, like you. Physics was never supposed to give you meaning. It was supposed to tell you what is consistent. Once you stop asking physics to answer questions it was never meant to answer, it becomes extraordinarily clear about the ones it can. Reality is not what feels solid. It is not what feels immediate. It is not what feels obvious. Reality is what remains when you strip away perspective, memory, expectation, and language, and ask only one thing: what must be true for the world to behave the way it does? That answer is never intuitive. It is never comforting, and it has never been optional. You were taught to think reality was simple and visible, and that science would just fill in the details. What science actually did was show that the simplicity was an illusion, and the details were the structure. Reality is not what you thought it was because what you thought it was came from how it feels to be inside it. Physics is what happens when you refuse to confuse feeling with fact. And once you make that refusal, the universe stops looking mysterious and starts looking inevitable. Not because it's easy, but because it's consistent. At the very end of this question, there is a temptation to ask for something solid to hold on to. Some final statement like, so reality is X? A noun, a thing, a definition you can keep in your pocket and use to feel oriented again. Physics does not give you that. And the reason it doesn't is not cruelty. It's precision. Reality is not a substance. It is not a medium. It is not a collection of ingredients. Every time physics tried to reduce reality to a thing, the thing dissolved into structure. Atoms dissolved into fields. Fields dissolved into interactions. Interactions dissolved into rules that constrain possibilities. What remains is not emptiness. It is necessity. Reality is whatever must be the case. For the universe to behave consistently across all perspectives, that is not a poetic answer. It is a brutally technical one. You don't ask what a rule is made of. You ask whether it holds. You don't ask where a constraint is located. You ask what it forbids and what it allows. Reality at the deepest level, physics reaches, looks much more like that than like anything you can picture. This is why the question, what exists, really, keeps leading people astray. It assumes existence is a property something has all by itself. Physics shows that existence is something inferred from participation in a lawful structure. If something can influence and be influenced in consistent ways, it is real. If removing it breaks the predictions, it is real. If it is required for the structure to hold together, it is real. Everything else is optional description. This is also why the universe does not feel like it has a center. Because it doesn't. There is no privileged place, no privileged moment, no privileged observer. Reality does not organize itself around where you happen to be standing, or when you happen to be alive. That realization feels unsettling only if you expected the universe to care. It doesn't. But that indifference is not nihilism. It is freedom from anthropocentrism. You are not special because the universe revolves around you. You are special because you are a part of a structure complex enough to ask what it is. Your thoughts about reality are themselves real events. They are not floating outside the universe commenting on it. They are part of the same network of interactions, governed by the same constraints. Once you see that, the question, what is reality actually, answers itself in a way no sentence can fully capture. Reality is not behind appearances. It is not underneath phenomena. It is not hidden beyond perception. Reality is the totality of lawful relationships that make appearance, phenomena, and perception possible in the first place. That's why every attempt to replace it with a picture fails. Pictures privilege a viewpoint. Reality does not. The mistake was thinking reality had to be something you could imagine. You were taught that understanding meant being able to picture. Physics teaches you that understanding often means giving up the picture and trusting the structure. This is why Feynman was so resistant to metaphysical language. He knew how quickly it smuggled in assumptions that physics had already outgrown. He preferred questions that could be answered by pointing to what changes when you change conditions. That's the only honest approach. Change the frame, change the scale, change the energy, change the observer. What stays the same?